Chapter 3. The relationship between rate of profit and rate of surplus value. As was indicated at the close of the previous chapter, we assume here, as throughout this part, that the sum of the profit that accrues to a given capital is the same as the total sum of surplus value which this capital produces in a given period of circulation. We therefore ignore, for the time being, the division of this surplus value into the various subordinate forms, interest, ground rent, taxes, etc., as also the fact that surplus value by no means coincides in the majority of cases with profit, as the latter is appropriated by way of the prevailing rate of profit, which we shall return to in Part 2. Insofar as profit is taken as quantitatively equal to surplus value, its magnitude and the magnitude of the rate of profit are determined by simple numerical ratios, the numbers involved being given or definable in each individual case. Our investigation is firstly, therefore, a purely mathematical one. We shall keep the symbols that were used in the first and second volumes. The total capital C is divided into constant capital small c and variable capital V, and produces a surplus value S. The ratio between this surplus value and the variable capital advanced, i.e. S over V, we call the rate of surplus value, and we denote it by S prime. Since S over V is equal to S prime, S is equal to S prime times V. If this surplus value is related to the total capital, instead of just the variable capital, it is called profit, which we denote P, and the ratio between the surplus value and the total capital C, i.e. S over C, is known as the rate of profit, P prime. We therefore have P prime is equal to S over C, which is equal to S over small c plus V. And if we substitute the S for the value of S prime times V, as above, we have P prime is equal to S prime times V over C, which is equal to S prime times V over small c plus V. An equation which can also be expressed as the proportionality. The ratio P prime to S prime is equal to the ratio V to C. Rate of profit is to the rate of surplus value as variable capital is to the total capital. It follows from this proportionality that P prime, the rate of profit, is always smaller than S prime, the rate of surplus value, since V, the variable capital, is always smaller than C, variable and constant capital. The only exception is the case, impossible in practice, where V is equal to C, and where the capitalist thus advances no constant capital, no means of production but simply wages. But a further series of factors have also to be taken into account in our analysis, factors which affect the sizes of small c, V, and S in a decisive way, and which must therefore be briefly mentioned. Firstly, the value of money. This we can take as constant throughout. Secondly, the turnover. We should ignore this factor completely for the time being, since its influence on the profit rate will be dealt with in a later chapter. Here, we shall simply anticipate the point that the formula P prime equals S prime times V over C is strictly correct only for a single turnover period of the variable capital, while for the annual turnover, the simple rate of surplus value S prime has to be replaced by S prime times N, the annual rate of surplus value, N standing for the number of turnovers that the variable capital makes in the course of a year. See Volume 2, Chapter 16. The third factor involved is the productivity of labor, whose influence on the rate of surplus value we have already gone into in some detail in Volume 1, Part 4. This can, however, also exert a direct influence on the rate of profit, at least that of an individual capital, if, as explained in Volume 1, Chapter 12, the individual capital operates with a productivity higher than the social average, produces its products at a lower value than the average social value of the same commodity, and in this way realizes an extra profit. But we shall also leave this case out of consideration here, as in this part we also proceed from the assumption that commodities are produced under normal social conditions and are sold at their values. We therefore assume in each individual case that the productivity of labor remains constant. In actual fact, the value composition of the capital applied in a particular branch of industry, i.e. a specific ratio between variable and constant capital, expresses in each case a definite level of labor productivity. Thus, as soon as this ratio experiences any change that is not simply due either to a change in the value of the material components of the constant capital or to a change in wages, the productivity of labor must also have undergone a change, and we shall therefore find often enough that the changes in the factors small c, V, and S also involve changes in labor productivity. The same applies to the remaining three factors: the length of the working day, the intensity of labor, and wages. Their influence on the mass and rate of surplus value was developed in detail in Volume 1, Chapter 17. We can well understand, therefore, how even if we proceed for the sake of simplicity from the assumption that these three factors remain constant, the changes that V and S undergo nevertheless involve changes in the size of these determining moments of theirs. And we may briefly remind ourselves here that wages affect the size and the rate of surplus value in the opposite direction to the length of the working day and the intensity of labor. A rise in wages reduces surplus value, while an extension of the working day and a greater intensity of labor both increase it. Let us take, for example, a capital of 100, producing a surplus value of 20 with 20 workers in a 10-hour working day, and a total weekly wage bill of 20. We then have ADC plus 20V plus 20S. S prime is equal to 100%, P prime is equal to 20%. If the working day is now extended to 15 hours, without an increase in wages, the total value produced by the 20 workers is increased from 40 to 60, the proportion of 10 to 15 being equivalent to the proportion 40 to 60. Since V, the wages paid, remains the same, the surplus value rises from 20 to 40, and we have ADC plus 20V plus 40S. S prime equals 200%, P prime equals 40%. If the wage for the same 10 hours labor falls from 20 to 12, we then have the same total value product of 40 as before, but differently distributed. V falls to 12 and thus leaves a remainder of 28 for S. We then have ADC plus 12V plus 28S. S prime equals 233 and 1/3%. P prime is equal to 28 over 92, or 30 and 10/23%. We see, therefore, how an extension of the working day, or alternatively an increase in the intensity of labor, and a fall in wages, both raise the mass, and with it the rate, of surplus value. Conversely, a rise in wages, with other circumstances remaining the same, would reduce the rate of surplus value. If V grows owing to a rise in wages, this does not express an increased quantity of labor, but simply its dearer payment. S prime and P prime do not rise, but fall. It is already evident here that changes in the working day, the intensity of labor, and wages cannot take place without a simultaneous change in V and S and their relationship, and thus also in P prime, the ratio between S and small c plus V, the total capital. And it is also evident that changes in the ratio of S to V also involve changes in at least one of the three conditions of labor that have been mentioned. Here we see precisely the special organic connection that the variable capital has with the movement of the capital as a whole and its valorization, as well as its distinction from the constant capital. The constant capital, insofar as the formation of value is concerned, is only important on account of the value that it has. It is quite immaterial here as far as value formation is concerned, whether a constant capital of 1,500 pounds represents 1,500 tons of iron at 1 pound a ton, or 500 tons at 3 pounds. The quantity of actual material in which its value is expressed is completely unimportant for the formation of value and for the rate of profit, which varies in the opposite direction to the value of the constant capital, irrespective of what relationship the increase or decrease in this value has to the mass of material use values that it represents. The case of the variable capital is completely different. What matters above all here is not the value that it actually has, the amount of labor objectified in it, but rather this value as a mere index of the total labor that it sets in motion, which is not expressed in it. The difference between this total labor and the labor expressed and therefore paid for in the variable capital, i.e. the portion that forms surplus value, is greater in proportion as the labor contained in the variable capital gets smaller. Say that a working day of 10 hours is equal to 10 shillings. If the necessary labor, the labor that replaces wages, i.e. replaces the variable capital, is 5 hours, then the surplus value is 5 shillings. If the necessary labor is 4 hours, being 4 shillings, then the surplus labor is 6 hours, and the surplus value 6 shillings. Hence, as soon as the value of the variable capital ceases to be an index of the mass of labor that it sets in motion, and the basis of this index itself changes, the rate of surplus value changes in the opposite direction and in inverse proportion. We can now move on to apply the above equation for the profit rate, P prime equals S prime times V over C, to the various possible cases. We shall let the individual factors of S prime times V over C vary successively in value, and establish the effect of these changes on the rate of profit. We thus obtain various sets of cases which we can consider either as successive changes in circumstances for the action of one and the same capital, or indeed as different capitals, existing simultaneously alongside one another and brought in for purposes of comparison, for example from different branches of industry or from different countries. If it therefore appears forced, or practically impossible, to interpret some of our examples as chronologically successive states of one and the same capital, this objection disappears as soon as they are viewed as the result of a comparison between separate capitals. We shall therefore divide the product, S prime times V over C, into its two factors S prime and V over C. First, we shall take S prime as constant and investigate the effect of possible variations in V over C. Then take the fraction V over C as constant and put S prime through its possible variations. Finally, we shall take all the factors as variable and in this way exhaust all the cases from which the laws governing the profit rate may be derived. Case number 1. S prime constant, V over C variable. This case, which comprises a number of subordinate ones, can be covered by a general formula. If we have two capitals, C and C1, with their variable components V and V1 respectively, a common rate of surplus value S prime, and rates of profit P prime and P prime 1, then P prime is equal to S prime times V over C, P prime 1 is equal to S prime times V1 over C1. C and C1, as well as V and V1, will then stand in certain definite ratios. And if C1 over C is equal to E, and V1 over V is equal to small e, then C1 is equal to E times C, and V1 is equal to small e times small v. By substituting these values into the above equation for P prime 1, we obtain P prime 1 is equal to the product of S prime and the fraction small e times V over E times C. We can also obtain a second formula from the above two equations if we transform them into the following proportionality. The ratio P prime to P prime 1 is equal to the ratio S prime times V over C to S prime times V1 over C1, which is equal to the ratio V over C to V1 over C1. Since the value of a fraction remains the same if numerator and denominator are both multiplied or divided by the same number, we can reduce V over C and V1 over C1 to percentages by taking both C and C1 as 100. We then have V over C is equal to V over 100, and V1 over C1 is equal to V1 over 100. Multiplying the above proportionality by 100 to remove these denominators of 100, we get the ratio of P prime to P prime 1 is equal to the ratio of V to V1. In other words, given any two capitals functioning with the same rate of surplus value, the rates of profit stand in the same proportion as the variable components of the capitals, each calculated as a percentage of its total capital. These two forms cover all cases of variation in V over C. Before we investigate each of these particular cases, one further remark. Since C is the sum of small c and V, the constant and the variable capital, and since the rate of surplus value as well as the profit rate is customarily expressed as a percentage, it is generally convenient to take the sum of small c and V as also equal to 100, i.e. to express small c and V in percentages too. It is not immaterial for determining the mass of profit, but it is, so far as the rate of profit is concerned, whether we say that a capital of 15,000, of which 12,000 is constant and 3,000 variable, produces a surplus value of 3,000, or whether we reduce the capital to percentages. 15,000 C is equal to 12,000 small c plus 3,000 V plus 3,000 S. 100 C is equal to 80 small c plus 20 V plus 20 S. In both cases, the rate of surplus value S prime equals 100%. And the rate of profit P prime equals 20%. It is the same if we compare two capitals with one another, for example comparing the above capital with the second one. 12,000 C equals 10,800 small c plus 1,200 V plus 1,200 S, and 100 C equals 90 small c plus 10 V plus 10 S. Here, S prime equals 100% and P prime equals 10%, and the comparison with the previous capital is far easier to make in the percentage form. If, on the other hand, we are dealing with changes taking place in one and the same capital, the percentage form can be used only rarely, as it almost always obliterates these changes. If a capital passes from the percentage form, 80 small c plus 20v plus 20s, to the percentage form, 90 small c plus 10v plus 10s, we cannot tell whether the new percentage composition 90 small c plus 10v has come about by an absolute decline in v, or an absolute rise in small c, or both. The absolute magnitudes must also be known here, and in our analysis of the following particular cases of variation, it is precisely how this change has come about that matters. Whether the 80 small c and 20v became 90 small c and 10v because 12,000 small c plus 3,000 v underwent a transformation, say into 27,000 small c plus 3,000 small v, 90 constant and 10 variable in percentage terms, i.e. through an increase in the constant capital, the variable capital remaining the same, or whether it assumed this new shape through a reduction in the variable capital with the constant capital remaining the same, i.e. because it changed into 12,000 small c plus 1,333 and 1/3 v, also 90 constant and 10 variable in percentage terms, or finally through a change in both these quantities, resulting in 13,500 small c plus 1,500 v. Again, 90 and 10 in percentage terms. But we will have to analyze all these cases in succession, thereby dispensing with the convenience of the percentage form, or only applying it as a supplement to the main argument. Subcase 1. S prime and C constant, V variable. If there is a change in the magnitude of V, C can remain unaltered only if its other component, the constant capital c, changes by the same amount as V but in the opposite direction. If C was originally 80 constant plus 20 variable being 100 and V is then reduced to 10, C can remain at 100 only if the constant capital rises to 90 c plus 10V being 100. In general, if V is changed to V plus or minus D, to V increased or decreased by another variable D, then small c must vary by the same amount in the opposite direction in order that the condition of the present case may be satisfied. In the same way, given an unaltered rate of surplus value, S prime, but a changing variable capital, the mass of surplus value must change, since S is equal to S prime times V, and one of the factors of S prime times V, namely V, has been given another value. The assumptions of the case at hand, together with the original equation, P prime is equal to S prime times V over C, give us the second equation, P prime 1 equals S prime times V1 over C by variation of V. V has now been changed to V1, and we have to find P prime 1, the ensuing new rate of profit. This is found by the appropriate proportionality. P prime is to P prime 1 as S prime times V over C is to S prime times V1 over C, or V to V1. Or with the rate of surplus value and the total capital both remaining the same, the original profit rate is related to the new profit rate arrived at by a change in the variable capital as the original variable capital is to the new variable capital. If the capital was originally, as above, 15,000 C, being composed of 12,000 constant plus 3,000 variable plus 3,000 surplus, and it is now 15,000 C being composed of 13,000 constant plus 2,000 variable plus 2,000 surplus, then C equals 15,000 and S prime equals 100% in both cases, and the rate of profit in case 1, 20%, is related to that in case 2, 13 1/3%, as the variable capital in case 1, 3,000, is related to that variable capital in case 2, 2,000, i.e. the ratio 20% to 13 1/3% is equal to the ratio 3,000 to 2,000. The variable capital can either rise or fall. Let us first take an example in which it rises. Say that a capital is originally constituted and functions as follows. 100 constant plus 20 variable plus 20 surplus. C is equal to 120. S prime equals 50%. P prime equals 8 1/3%. The variable capital now rises to 30. According to our assumption, the constant capital must fall from 100 to 90, so that the total capital remains the same at 120. The surplus value produced must rise by 15, given the same rate of surplus value of 50%. We then have 90 constant plus 30 variable plus 15 surplus. C is equal to 120, S prime is equal to 50%, and P prime is equal to 12 1/2%. Let us proceed first of all on the assumption that wages are unchanged. In that case, the other factors involved in the rate of surplus value, i.e. the working day and the intensity of labor, must also have remained the same. The increase in V, from 20 to 30, can only mean, therefore, that half as many workers as before are employed. This means that the total value produced also rises by a half, from 30 to 45, while it is divided just as before, with 2/3 going to wages and 1/3 to surplus value. At the same time, however, as the increase in the number of workers, the constant capital, the value of the means of production, has fallen from 100 to 90. We have, therefore, a case of a decline in labor productivity, combined with a simultaneous decline in constant capital. Is this case economically possible? In agriculture and the extractive industries, where a decline in labor productivity and a consequent increase in the number of workers employed is easy to comprehend, this process, within the confines of capitalist production and on its basis, is linked not with a decline in constant capital but with an increase. Even if the above decline in constant capital were occasioned simply by a fall in price, an individual capital would be able to make the transition from example 1 to 2 only under quite exceptional conditions. With two independent capitals, however, invested in different countries or in different branches of agriculture or extractive industry, it would be by no means unusual if in one case more workers, hence a bigger variable capital, were employed and worked with less expensive or less plentiful means of production than in the other case. Let us now drop the assumption that wages remain the same and explain the rise in variable capital from 20 to 30 in terms of an increase of a half in wages. We then have a completely different picture. The same number of workers, let us say 20, carry on working with the same or only insignificantly reduced means of production. If the working day remains unaltered, at 10 hours for example, the total value produced remains similarly unaffected. It is still 30, just as before. But this 30 would now be fully employed in replacing the variable capital of 30 that was advanced. The surplus value would have completely disappeared. We presupposed, however, that the rate of surplus value remained constant at 50%, as in example number 1. This is possible only if the working day is also extended by half and increased to 15 hours. 20 workers would then produce in 15 hours a total value of 45, and all the conditions would be fulfilled. 90 constant plus 30 variable plus 15 surplus, C is equal to 120, S prime is equal to 50%, and P prime is equal to 12.5%. In this case, the 20 workers need no more means of labor, tools, machinery, etc. than in example number 1. It is only the raw or ancillary materials that would have to be increased by half. If these materials fall in price, the transition from 1 to 2 would be much more possible as an economic phenomenon given our assumptions, even for one and the same capital. And the capitalist would be compensated, at least partially, by a bigger profit for the loss that the devaluation of his constant capital would have caused him. Let us now assume that the variable capital falls instead of rising. Then we need only reverse our above example, taking number 2 as the original capital and moving from number 2 to number 1. 90 constant plus 30 variable plus 15 surplus is then transformed into 100 constant plus 20 variable plus 10 surplus. And it is readily apparent that by this reversal, the rates of profit in the two cases and the conditions governing their mutual relationship are not changed in the slightest. If V falls from 30 to 20 because 1/3 less labor is engaged with an increased constant capital, this is simply the normal case in modern industry. Rising productivity of labor, the operation of greater quantities of means of production by fewer workers. And in part 3 of this volume, we shall see how this movement is necessarily bound up with a simultaneous fall in the rate of profit. But if the reason for the fall in V from 30 to 20 is that the same number of workers are employed at a lower wage rate, then so long as the working day is unchanged, the total value product remains unaltered at 30V plus 15S, being 45. Since V has fallen to 20, the surplus value has risen to 25, and the rate of surplus value from 50% to 125%, which would be against our assumption. In order to remain within the limits of our example, the surplus value at a rate of 50% must fall instead to 10, and thus the total value produced from 45 to 30, and this is possible only if the working day is cut by 1/3. We then have, as above, 100 constant plus 20 variable plus 10 surplus. S prime equals 50% and P prime equals 8 1/3%. We need hardly point out that a reduction in working hours of this kind combined with a fall in wages would not occur in practice. But this is beside the point. The rate of profit is a function of several variables, and if we want to know how these variables act on the profit rate, we must investigate in turn the individual effect of each, irrespective of whether an isolated effect of this kind is economically possible or not, in the case of one and the same capital. Subcase 2. S prime constant, V variable, C altered by the variation of V. This case is different from the previous one only in degree. Instead of decreasing or increasing by the same amount as the variable capital, the constant capital now remains constant. But under today's conditions of large-scale industry and agriculture, variable capital is only a relatively small portion of the total capital, and hence any reduction or growth in the total capital that is brought about by a change in the variable capital is also relatively slight. If we start once again with a capital such as, example number 1, 100 constant plus 20 variable plus 10 surplus, C is equal to 120, S prime at 50%, and P prime at 8 1/3%, this might perhaps be changed into something like, example number 2, 100 constant plus 30 variable plus 15 surplus, C is equal to 130, S prime is at 50%, and P prime is at 11 7/13%. The opposite case of a decline in the variable capital would again be illustrated by the reverse transition from 2 to 1. Economic conditions here would be essentially the same as in the previous case, and hence need no further explanation. The transition from 1 to 2 involves a decline of 1/3 in the productivity of labor, or the operation of 100 constant requires half as much labor again in 2 as it does in 1. This case is possible in agriculture. Whereas in the previous case, the total capital was held constant by the conversion of constant capital into variable or vice versa, now the increase in the variable portion means that the extra capital is tied up, while a decrease involves the release of capital that had previously been needed. Subcase 3. S prime and V constant, small c, and therefore also c, variable. In this case, the equation P prime equals S prime times V over C is changed to P prime 1 equals S prime times V over C1. And by canceling out on both sides, we get the proportionality P prime 1 is to P prime as C is to C1. With the same rate of surplus value and the same variable capital, the profit rate stands in inverse proportion to the total capital. Say that we have 3 capitals or 3 different states of the same capital. State number 1, 80 constant plus 20 variable plus 20 surplus. C equals 100, S prime is at 100%, and P prime is at 20%. State number 2, 100 constant plus 20 variable plus 20 surplus. C is at 120, S prime at 100%, and P prime is at 16 2/3%. And state number 3, 60 constant plus 20 variable plus 20 surplus. C is at 80, S prime is at 100%, and P prime is at 25%. Then 20% is to 16 2/3% as 120 is to 100, and 20% is to 25% as 80 is to 100. The general formula given above for variations in V over C, where S prime was constant, was P prime 1 equals the product of S prime and small e times V over E times C. It now becomes P prime 1 equals the product of S prime and V over E times C. Since V does not undergo any alteration, and the factor small e, which is V1 over V, is therefore 1. Since S prime times V is equal to S, the mass of surplus value, and since S prime and V both remain constant, S is also unaffected by any variation in C. The mass of surplus value remains the same as before the change. If the constant capital were to fall to 0, we would have P prime equals S prime. The rate of profit is equal to the rate of surplus value. The alteration in small c can come about either from a change merely in the value of the material elements of the constant capital, or from a changed technical composition of the total capital, i.e. a change in the productivity of labor in the branch of production in question. In the latter case, the productivity of social labor, which rises with the development of large-scale industry and agriculture, would successively move from 3 to 1 and from 1 to 2 in the above example. A quantity of labor that is paid 20 and produces a value of 40 would start by being used to operate a mass of means of labor to the value of 60. If its productivity rose, the means of labor put into operation would grow first to 80 and then to 100 if their value remained the same. The reverse sequence would indicate a decline in productivity. The same quantity of labor would set less means of production in motion, and the business would be cut back, as can well happen in agriculture, mining, etc. A saving in constant capital both increases the rate of profit and releases capital as well, and this is important for the capitalist. We shall return to this point later, as well as investigating the effect of changes in the prices of the elements of constant capital, raw materials in particular. We see here again how a variation in constant capital has the same effect on the rate of profit irrespective of whether this variation is brought about by an increase or decrease in the material components of it, or simply by a change in their value. Subcase 4. S prime constant, V, small c, and C all variable. In this case, the above general formula for changes in the profit rate, P prime 1 equals the product of S prime and small e times V over E times C, still applies. It results from this that with the rate of surplus value remaining the same, A, the rate of profit falls if E is greater than small e, i.e. if the constant capital is increased in such a way that the total capital increases more sharply than the variable capital. If a capital of 80 constant plus 20 variable plus 20 surplus is changed to a composition of 170 constant plus 30 variable plus 30 surplus, then S prime remains at 100%, but V over C falls from 20 over 100 to 30 over 200, despite the fact that V has increased as well as C, and the rate of profit accordingly falls from 20% to 15%. B, the rate of profit remains unchanged only if small e equals E, i.e. if the fraction V over C retains the same value despite the apparent change, thus if both numerator and denominator are multiplied or divided by the same figure. 80 constant plus 20 variable plus 20 surplus, and 160 constant plus 40 variable plus 40 surplus evidently have the same profit rate of 20%, because S prime remains at 100% and V over C equals 20 over 100 and 40 over 200 exhibits the same value in both examples. C. The rate of profit rises if small e is greater than E, i.e. if the variable capital rises more sharply than the total capital. If 80 constant plus 20 variable plus 20 surplus becomes 120 constant plus 40 variable plus 40 surplus, then the rate of profit of 20% rises to 25%, because with S prime unaltered, V over C, which equaled 20 over 100, has risen to 40 over 160, from 1/5 to 1/4. Where V and C both change in the same direction, we can conceive this change in their magnitudes as if both vary to a certain extent in the same ratio, so that up to this point V over C remains unaltered. Beyond this point, then, only one of them varies, and we can thereby reduce this more complicated case to one or the other of the previous simpler ones. If 80 constant plus 20 variable plus 20 surplus changes to 100 constant plus 30 variable plus 30 surplus, the ratio between V and small c, and therefore also between V and C, remains unaltered up to the point 100 constant plus 25 variable plus 25 surplus. The rate of profit, therefore, is so far unaffected. We can now take this 100 small c plus 25V plus 25S as our starting point. We find that V rises by 5 to 30V, and C thereby rises from 125 to 130, and we are thus faced with case 2, that of a variation simply in V, and the variation in C that this occasions. The rate of profit, which was originally 20%, is increased by this addition of 5V to 23 1/13%, given the same rate of surplus value. The same reduction to a simpler case can also take place even if V and C move in opposite directions. Let us proceed again from 80 constant plus 20 variable and 20 surplus, and let this change to the form 110 constant plus 10 variable and 10 surplus. A change to 40 small c plus 10V plus 10S would have kept the profit rate the same as it was originally, i.e. at 20%. The addition of 70 small c to this intermediate form makes it fall to 8 1/3%. We have again reduced the example to a variation in only one of the variables, i.e. small c. Thus, the simultaneous variation of V, small c, and C does not offer any new aspects, and always leads back in the last analysis to a case in which only one factor is variable. Even the sole case that still remains has really been dispensed with already, i.e. the case in which V and small c remain numerically the same, but their material elements undergo a change in value. V represents a different quantity of labor set in motion, and small c a different quantity of means of production. In the capital of 80 constant and 20 variable and 20 surplus, the 20V might originally represent the wages of 20 workers for a 10-hour working day. Say that the wage of each worker now rises from 1 to 1 1/4. In this case, the 20V only suffices to pay 16 workers instead of 20. But if the 20 workers produced a new value of 40 in their 200 hours work, then the 16 in a 10-hour day that amounts to 160 hours work in all will produce a value of only 32. After subtracting 20V for wages, only 12 of the 32 is left for surplus value, and the rate of surplus value would then have fallen from 100% to 60%. But since, according to our assumption, the rate of surplus value has to remain constant, the working day must be extended by a quarter, from 10 hours to 12.5. If 20 workers produce a value of 80 in the working day of 10 hours, i.e. 200 hours work in all, 16 workers produce the same value in 12.5 hours per day, which also comes to 200 hours, so that the capital of 80 constant and 20 variable still produces the same surplus value of 20 as it did before. Conversely, if wages fall in such a way that 20V covers the wages of 30 workers, S prime can remain constant only if the working day is reduced from 10 hours to 6 2/3. 20 times 10 equals 30 times 6 2/3, which is 200 working hours. We have already explained in Essentials how small c can retain the same value expression in money throughout all these conflicting assumptions, while representing different quantities of means of production which correspond to the change conditions. This case would, however, be very exceptional in its pure form. As far as the change in value of the elements of small c is concerned, a change that increases or decreases certain elements while leaving their value sum, small c, unaltered, this disturbs neither the rate of profit nor the rate of surplus value, as long as it does not bring with it any alteration in the magnitude of V. In this way, we have dealt with all possible cases of variation of V, small c, and C in our equation. We have seen how the profit rate can fall, rise, and remain the same, with the rate of surplus value constant throughout, insofar as the slightest alteration in the ratio between V and small c, or C, is sufficient to alter the profit rate as well. It has also become evident that there is always a limit to the variation of V, beyond which it is economically impossible for S prime to remain constant. Since any unilateral variation of C must similarly reach a limit at which V can no longer remain constant, it is clear that limits are placed on all possible variations of V over C, beyond which S prime must also vary. In the case of these variations in S', which we shall now turn to investigate, the mutual interaction of the various different variables in our equation appears even more clearly. Case number 2. S' variable. We can obtain a general formula for the rate of profit corresponding to different rates of surplus value, irrespective of whether V over C remains constant or also varies, if we convert the equation P' equals the product of S' and V over C into the equation P'1 equals the product of S'1 and V1 over C1, in which P'1, S'1, V1, and C1 stand for the new values of P', S', V, and C. We then get P' is to P'1, as S' times V over C is to S'1 times V1 over C1, and therefore P'1 equals S'1 over S times V1 over V times C over C1 times P'. Subcase number 1. S' variable, V over C constant. In this case, we have the equations P' equals S' times V over C, and P'1 equals S'1 times V over C, such that V over C has the same value in both cases. It follows, therefore, that P' is to P'1 as S' is to S'1. The rates of profit for two capitals of the same composition are in direct proportion to their respective rates of surplus value. Since the absolute magnitudes of V and C do not come into play in the fraction V over C, but simply the ratio between the two, this holds for all capitals of the same composition, whatever their absolute magnitude may be. A capital of 80 constant plus 20 variable plus 20 surplus, C is equal to 100, S' is equal to 100%, and P' is equal to 20%. And a capital of 160 constant plus 40 variable plus 40 surplus, C is equal to 200, S' is equal to 50%, and P' is equal to 10%. 100% is to 50%, as 20% is to 10%. If the absolute magnitudes of V and C are the same in both cases, the profit rates also stand in the same ratio as the masses of surplus value. P' is to P'1 as S' times V is to S'1 times V, which is equal to the ratio of S to S1. For example, 80 constant plus 20 variable plus 20 surplus, S' equals 100%, P' equals 20%. 80 constant plus 20 variable plus 10 surplus, S' equals 50%, P' equals 10%. The proportion 20% to 10% is equal to the proportion 100 times 20 to 50 times 20, or 20s to 10s. It is evident now that given capitals of the same composition, either absolutely or relatively, the rate of surplus value can vary only if either wages or the length of the working day or again the intensity of labor also vary. In the following three cases: number 1, 80 constant plus 20 variable plus 10 surplus, where S' is equal to 50% and P' is at 10%. Number 2, 80 constant plus 20 variable plus 20 surplus, where S' is at 100% and P' is at 20%. And number 3, 80 constant plus 20 variable plus 40 surplus, where S' is at 200% and P' is at 40%. The total value produced is 30 in number 1, being 20V plus 10S, 40 in number 2, and 60 in number 3. This can happen in three different ways. Firstly, if wages vary, so that 20V represents a different number of workers in each individual case. Let us assume that in case number 1, 15 workers are employed for 10 hours at a wage of 1 2/3 pounds to produce the value of 30 pounds, of which 20 replaces wages and 10 remains for surplus value. If wages fall to 1 pound, then 20 workers are employed for 10 hours and produce a value of 40 pounds, of which 20 pounds is wages and 20 surplus value. If wages fall yet further to 2/3 of a pound, then 30 workers are employed for 10 hours and produce a value of 60 pounds, of which 40 remains for surplus value after subtracting the 20 for wages. This case, that of a constant percentage composition of capital, constant working day, constant intensity of labor with changes in the rate of surplus value brought about by changes in wages, is the only one that meets Ricardo's assumption. Quote, profits would be high or low exactly in proportion as wages would be low or high. End quote from Principles, Chapter 1, Section 3. Secondly, it can happen if the intensity of labor varies. In this case, for example, 20 workers might make 30 items of a certain commodity in case number 1, 40 in case number 2, and 60 in case number 3, working with the same means of labor for 10 hours a day, with each item representing a new value of 1 pound over and above the value of the means of production consumed in it. Since 20 items, being 20 pounds, are always needed to replace wages, there remains for surplus value in case number 1, 10 items, being 10 pounds. In case number 2, 20 items being 20 pounds, and in case number 3, 40 items at 40 pounds. The third possibility is that the working day varies in length. If 20 workers work with the same intensity for 9 hours in case number 1, 12 hours in case number 2, and 18 hours in case number 3, their total products will stand in the ratio of 9 to 12 to 18, i.e. 30 to 40 to 60. And since wages are 20 each time, there again remains 10, 20, or 40 left over for surplus value. A rise or fall in wages thus affects an opposite change in the rate of surplus value, while a rise or fall in the intensity of labor, or an extension or reduction of the working day, both affect a change in the same direction, and with V over C constant, the rate of profit is therefore similarly affected. Subcase number 2. S prime and V variable, C constant. In this case, we have the proportionality P prime is to P prime 1, as S prime times V over C is to S prime 1 times V1 over C, and as S prime times V is to S prime 1 times V1, which is the same as S to S1. The rates of profit stand in the same ratio as the respective masses of surplus value. Variation in the rate of surplus value, with variable capital remaining the same, means a change in the size and distribution of the value product. Simultaneous variations in V and S prime similarly entails a different distribution, but not always a change in the magnitude of the value product. 3 cases are possible. A. The variations in V and S prime take place in opposite directions, but by the same amount. For example, 80 constant, 20 variable, and 10 surplus, S prime is at 50%, P prime is at 10%, 90 constant, 10 variable, and 20 surplus, S prime is at 200%, P prime is at 20%. Here, the value product is the same in both cases, and so too therefore is the quantity of labor that is performed. 20V plus 10S is equal to 10V plus 20S, being 30. The distinction is simply that in the first case, 20 is paid for wages and 10 for surplus value, while in the second case, wages amount only to 10 and surplus value is therefore 20. This is the only case in which a simultaneous variation in V and S prime leaves the number of workers, the labor intensity, and the length of the working day unaffected. B. The variations in S prime and V still occur in opposite directions, but not to the same extent in each case. Either the variation in V must predominate or that in S prime. Number 1. 80 constant plus 20 variable plus 20 surplus, S prime is at 100% and P prime is at 20%. Number 2. 72 constant plus 28 variable plus 20 surplus, S prime is at 71 5/7%, P prime is at 20%. Number 3. 84 constant plus 16 variable plus 20 surplus, S prime is at 125%, and P prime is again at 20%. In case number 1, a value product of 40 involves a payment of 20V. In case number 2, a product of 48, a payment of 28V. And in case number 3, one of 36, a payment of 16V. Both the value product and the wages have altered, but an alteration in the value product means an alteration in the quantity of labor performed, and therefore either in the number of workers, the duration of labor, or its intensity, if not more than one of these 3. C. S prime and V both vary in the same direction. In this case, the effect of one reinforces that of the other. 90 constant, 10 variable, and 10 surplus. S prime is at 100%, P prime is at 10%. 80 constant, 20 variable, and 30 surplus. S prime is at 150%, P prime is at 30%. 92 constant, 8 variable, and 6 surplus. S prime is at 75%, P prime is at 6%. Here, too, the 3 value products are different, i.e. 20, 50, and 14, and this difference in the quantity of labor in each case can again be reduced to a difference in the number of workers, the duration or intensity of labor, or any combination of these factors. Subcase number 3. S prime, V, and C all variable. This case offers no new aspects and is settled by the general formula given under heading 2, where S prime was variable. The impact of a change in the rate of surplus value on the profit rate can thus be covered by the following cases. 1. P prime is increased or diminished in the same ratio as S prime if V over C remains constant. 80 constant plus 20 variable plus 20 surplus, S prime is at 100%, P prime at 20%. 80 constant, 20 variable, and 10 surplus, S prime is at 50%, P prime is at 10%. 100% is to 50% as 20% is to 10%. 2. P prime rises or falls in a higher ratio than S prime if V over C moves in the same direction as S prime, i.e. increases or decreases according to whether S prime increases or decreases. 80 constant plus 20 variable plus 10 surplus, S prime is at 50%, P prime is at 10%. 70 constant, 30 variable, and 20 surplus, S prime is at 66 2/3%, and P prime is at 20%. The proportion of 50% to 66 2/3%, the proportion of S prime in the first case and S prime in the second case, is less than the proportion of 10% to 20%, i.e. P prime in the first case as to P prime in the second case. 3. P prime rises or falls in a lower ratio than S prime if V over C changes in the opposite direction to S prime but in a lower ratio. 80 constant, 20 variable, and 10 surplus. S prime is at 50%, P prime is at 10%. 90 constant, 10 variable, and 15 surplus. S prime is at 150%, P prime is at 15%. The ratio of 50% to 150%, i.e. the first S prime to the second, is greater than the ratio of 10% to 15%. 4. P prime rises even though S prime falls, or falls even though S prime rises, if V over C changes in the opposite direction to S prime and in a higher ratio. 80 constant, 20 variable, and 20 surplus. S prime is at 100%, P prime is at 20%. 90 constant, 10 variable, and 15 surplus. S prime is at 150%, and P prime is at 15%. Here, the rate of surplus value has risen from 100% to 150%, while the rate of profit has fallen from 20% to 15%. 5. Finally, P prime remains constant even though S prime rises or falls, if V over C changes in the opposite direction to S prime but in exactly the same ratio. It is only this last case that still requires some further discussion. We saw above, with the variations in V over C, how one and the same rate of surplus value can be expressed in the most varied rates of profit. Here we see that one and the same rate of profit can be based on very different rates of surplus value. But while with S prime constant, any change whatsoever in the ratio of V to C is sufficient to induce a variation in the rate of profit, a change in S prime must involve an exactly corresponding but opposite change in V over C if the profit rate is to remain the same. This is possible only very exceptionally in the case of one and the same capital, or with two capitals in the same country. Let us take, for example, a capital consisting of 80 constant, 20 variable, and 20 surplus. The value of the capital is therefore 100. The rate of surplus value is 100%, the rate of profit is 20%. And assume that wages fall in such a way that the same number of workers can be had for 16V as previously for 20V. With conditions remaining otherwise unchanged, we would then have 4V set free, giving 80 constant plus 16 variable plus 24 surplus. The value of the total capital is 96, the rate of surplus value is 150%, and the rate of profit is 25%. If P prime, the rate of profit, is still to be 20% as before, the total capital has to increase to 120, and the constant capital therefore to 104. That's 104 small c plus 16v plus 24s. The value of the total capital being 120, S prime being 150%, and P prime being 20%. This would be possible only if a change in the productivity of labor took place simultaneously with a fall in wages, and required this changed composition of capital. Or alternatively, if the money value of the constant capital rose from 80 to 104. In other words, a chance combination of conditions that only comes about in exceptional circumstances. In actual fact, a change in S prime, the rate of surplus value, which is not simultaneously a change in V, thus also giving rise to a change in the proportion of V to C, is conceivable only under quite special conditions, i.e. in those branches of industry in which only fixed capital and labor are applied, and the object of labor is provided by nature. The position is different when comparing rates of profit in two countries. Here, the same rate of profit expresses in most cases different rates of surplus value. It results from all these 5 cases, therefore, that a rising profit rate can correspond to a falling or rising rate of surplus value. A falling profit rate can correspond to a rising or falling rate of surplus value, and a rate of profit that remains the same can also correspond to a rising or a falling rate of surplus value. We have already shown under heading number 1, where S prime was constant and V over C was variable, that a rising, falling, or unchanged rate of profit can also correspond to a rate of surplus value that remains the same. The rate of profit is thus determined by 2 major factors, the rate of surplus value and the value composition of the capital. The effects of these 2 factors can be briefly summarized as follows, and we are able now to express the composition in percentages, since it is unimportant here in which of the 2 portions of capital the change originates. The rates of profit of 2 different capitals, or of one and the same capital in 2 successive and different states, are equal, 1. Given the same percentage composition and the same rate of surplus value, 2. Given unequal percentage compositions and unequal rates of surplus value if the product of the rate of surplus value and the percentage of the variable part of capital, the product of S prime and V, is the same in each case, i.e. the mass of surplus value reckoned as a percentage of the total capital. S is equal to S prime times V. In other words, when the factors S prime and V, the rate of surplus value and the variable capital, stand in inverse proportion to one another in the 2 cases. They are unequal, 1. Given the same percentage composition if the rates of surplus value are unequal, in which case they stand in the same ratio as these rates of surplus value. 2. Given the same rate of surplus value and different percentage compositions, in which case they stand in the same ratio as the variable portions of the capitals. And 3. Given different rates of surplus value and different percentage compositions, in which case they stand in the same proportion as the products S prime times V, i.e. as the masses of surplus value reckoned as a percentage of the total capital.